Hello, Math 157ers. This is Professor Caligero, and we're going to talk about Section 10.4, hypothesis testing for a proportion. All right. So the objectives are to test the hypotheses about a proportion, test hypotheses about a population proportion using the binomial probability distribution. Test hypotheses about a population proportion. Okay, so anytime we look for a point estimate of the population, it is x over n. X is the number of individuals that have the trait over the total number of individuals in the sample. Okay, and again, the sampling distribution of p hat is approximately normal with mean equal to p in standard deviation. Okay, so if I needed to calculate the sigma of p hat, it's just like in chapter 9, the square root of p times 1 minus p over n. But the big thing really here is we need to make sure that they satisfy these things. Sample is a simple random sample. N times p times 1 minus p is greater than or equal to 10, and the sample values are independent of each other. Okay, so these are really the most important things that are going to go on. Okay, so we need to make sure they're independent. N times p naught is greater than 1 minus p naught is greater than 10, and the sample is obtained by simple random sampling. So again, the two-tailed, left-tailed, and right-tailed tests look very similar to what we did for 10.3. We can have h naught p is equal to p naught, h1 p is not equal to p naught, and p naught is the assumed value of the population proportion. And then we can, in the left-tailed test, pointing to the left for h1, again, we use equality for the original hypothesis, p equals p naught, and then h1 is p is less than p naught, and so on. We're always going to select the level of significance, alpha, based on our seriousness of making a type 1 error. So this is how the test statistic is calculated. It's z naught minus p hat equals p hat, which is the test proportion, minus p naught over the square root of p naught times 1 minus p naught over n. And why do they use p naught when we do the standard error rather than p hat? Because when you test a hypothesis, you're always assuming the null is true. Okay, so in the classical approach, use the table, or I want you to use StatCrunch to find the critical value. And just in the two-tailed approach, so if, let's say, for example, and hold on, we said that our z of alpha equals 0.05, so that's like 95% level of confidence. So to find our z of alpha over 2, we're going to take the 0.05 and divide by 2. So our z of alpha over 2 should be I think it's 0.025, but I'm not feeling confident, so I'm just going to check that. Yeah, 0.025. I should trust my math skills a little bit more. 0.025. So the area in each of these tails would be 0.025, 0.025. If we come over to StatCrunch, let's see if StatCrunch is going to actually open in Internet Explorer. Doesn't always open when I use IE. Yep. We go to stat, excuse me, calculators, normal, and mean is 0, the standard deviation is 1, that's for our z. And what we can do is we can find the left-tailed number by putting in the error at point 025. And that gives us negative 1.95, which we always round to negative 1.96. And then, just to verify, on the other side, the other z of alpha over 2 should be positive 1.96, so let's make sure. Yep. So our critical value of z is negative and positive 1.96. So if we were to find our test statistic to be less than negative 1.96, so this value is negative 1.96, and this value is positive 1.96. If they were in that critical region, we would reject, and if they were in this kind of white, off-white region, we would fail to reject. And then the critical region for negative z of alpha over 2, we'll do an example of that. Let's say we're doing this at the, it's not even z of alpha over 2, because we're doing a left-tailed test. Let's say our alpha is 0.01. Just a 99% level of confidence. Means the area to the left needs to be equal to 0.01. So we come over here, we're going to say 0.01. So it's negative 2.32, which we probably would round to negative 2.33. Okay. And the right-tailed test would work the same way. It would just be greater than. So in a two-tailed test, if your test statistic is less than the negative z of alpha over 2, or it's greater than z of alpha over 2, we reject. In the left-tailed, if it's in that critical region, so it's less than negative z of alpha, we would reject. In the right tail, if it were greater than z of alpha, we would also reject. Okay. Now, there's a p-value approach, and we're not going to use tables to estimate p-values. We're going to use technology. In a two-tailed test, the sum of the area and the tails is the p-value. In the left tail, it's the area in the tail is the p-value. To the left is z0. And in the right tail approach, the area to the right is the p-value. If the p-value is less than alpha, you would reject the null hypothesis. Then you state your conclusions. Okay, so in 1997, 46% of Americans said they did not trust the media when it comes to fairly reporting the news fully. In a 2007 poll of 1,010 adults, 523 stated they did not trust the media. At the 0.05 level of significance, is there evidence to support the claim that the percentage of Americans that do not trust the media fully has increased? So let's write our H0. You always need to write your hypothesis. And instead of mu, we're going to P equals 0.46, and H1 is that P is greater than 0.46. So what is our P hat? Or our P hat, we're looking at the 2007 poll. Our P is 525 over 1010. And work it out with me. If you need to pause it for a second, go ahead. I got 0.519, so I'm going to go with 0.52. And our alpha equals 0.05 level of significance. It's a right tail test, the arrow is pointing to the right. So what we need to do is go back to StatCrunch, and you need to erase here. 0.05. We're going to make it greater than. And so our Z of alpha value is 1.648. I think we use 1.645 pretty standardly. 1.6448, so we're going to use 1.645. So our Z of alpha, no, it's 645, no, it's crowded. Please try to work along with me on this one. All right. So one thing I did not do, and I should have done, we have to verify the requirements. So it is a simple random sample. It doesn't specifically say that, but we can assume that. It's a poll of 1,010 adults nationwide. And then we go N times P. Our N is our sample N, which is 1010, times 0.46, because we're using the original P-naught that we're testing, 0.46, times 1 minus 0.46 ends up being 250.8. And the sample size needs to be less than 5% of the population size. So that's where that 0.05 N has to be greater than 0.05 N has to be greater than N. All right. So just like we did, H naught P is equal to 0.46. Level of significance is alpha equals 0.05. We got the same sample proportion because our sample proportion was 0.52. And then they calculate the test statistic to be 3.83. All right. Now, let 3.83. Now it is I need somewhere to draw. It's a right-tailed test, and our critical value of Z was 1.645, and our calculated Z is 3.83. So to me, that looks like it's in the critical region. And we reject the null. All right, so now let's go to StatCrunch and let me give you some other ways to approach this problem. Okay, stat, proportion statistic, one sample with summary. Our number of successes, I didn't write that down separately. I know our number of observations are 1010. 525. Hypothesis test that P is equal to, what was it, 0.46, and the alternative is that P is greater than 0.46. Let's compute. All right, look at our Z statistic right here. Our Z stat is 3.812 whatever, which is exactly what we got when we look at that problem. I went too far. So look down here. There's that Z, that same number. So you don't need to be calculating that Z. If you're doing this normal approach, you absolutely need your Z, and you need to know what your Z of alpha is. But we've gone through a few times now how to find that Z of alpha. So then you can just draw a normal curve, mark where your Z of alpha is, and decide if it's a left or right or a two-tailed test, and depending what number you get. Okay. Now, there's another approach. It's called the p-value approach. Okay. And that actually calculates the area under the normal distribution to the right of the test statistic. If you look here, there's our p-value. This p-value is less than 0.00001, which makes sense because that's way over on that normal curve. This is going to be a tiny little number. In the p-value approach, no matter if it's a left, right, or two-tailed test, if your p-value is less than your alpha, and in our case, our alpha was 0.05, well, obviously 0.0001 is less than 0.05, so we would reject. You get the same conclusion. A lot of people are only using the p-value approach, and I'm fine with you using the p-value approach. I actually kind of prefer it. Let's look here. So as long as the p-value is less than alpha, we reject the null hypothesis, and we say there is sufficient evidence at the 0.05 level of significance to conclude that the percentage of Americans that do not trust the media to report fully and accurately has increased. We can't say that it was our new percentage, but we can say that it was our new, okay. Now, 2006, 10.5% of all live births in the United States were to mothers under 20 years of age. A sociologist claims that birth to mothers under 20 years of age is decreasing. She conducted a simple random sample of 34 births, finds that 3 of them were to mothers under 20 years of age. Test that claim at the alpha 0.01 level of significance. Okay, so here's the problem. We have H0 equals P equals 0.105, which was like the 10.5% was the one we assumed to be true. H1 is less than 0.105. We have P0 is 0.105. There were 34 mothers sampled. So we're taking 35 times 0.105 times 1.405. So the sampling distribution of p hat is not normal. Okay. I'm looking at this. And I don't think we're going to do the binomial approach. I think we're going to stay away from the binomial. So let's look at a couple example problems. We're not going to look at the last part of that slide. Let's go back to work in R. And I am just going to remove any problems dealing with the binomial approach, if we have any of those. Okay. What am I looking for? I'm looking for my study plan. I need to find my chapter contents. Chapter 10, I'm going to 10.4, and we're going to do a couple questions that I wrote down. First one I want to look at is number 2. Let's be this one. Okay. H0 is P equals 0.2 versus the alternative that P is greater than 0.2. N is equal to 200. X is 55 and alpha is 0.05. So the first thing we need is our Z of alpha. It's a right tail test, so if we go into StatCrunch, and I'm hoping it's going to open. No, this version of StatCrunch is not opening. Okay, so we're going to go back to StatCrunch in this window. So work this along with me. H0 P equals 0.2, H1 P is greater than 0.2, N equals 200, x equals 55 and alpha equals 0.05. So just write all that stuff down. So the first thing we're going to do is to find our z of alpha. Stat, calculators, normal, right tail test, and it's 0.05. Compute, I think it's the 1.645. So in this classical approach, if I can draw, that's lovely. Nothing's working correctly on my computer. Oh, it's thinking. It's thinking. You going to open anything up for me? There we go. All right, so let's see what we have. H naught P equals 0.2. H1 P is greater than 0.2. Right. N equals 200. X is 55. And alpha 0.05. And our z of alpha, because we use the table, the calculator to look it up, is 1.645. It's a right tail test. The arrow is going to the right. Here's 1.645. So this becomes our rejection region. Okay. Quick test. Make sure we are okay to use this. 0.2 times, and it's n times p times 1 minus p has to be greater than 10. So we've got 200 times 0.2 times 1 minus 0.2. We have to make sure it's greater than or equal to 10. I'm pretty sure it's fine. And then 1 minus 0.2 is 0.8, so times 0.8, 32, we're good. Good to go. All right, so let's go back to StatCrunch. And we're going to go to Stat, Proportion Statistics, one sample, with summary. Number of successes was 55. Number of observations was 200. Hypothesis that P equals 0.2, and P is, alternative is really that it's greater than 0.2. Compute. All right, our Z statistic is 2.652. Go back and look at our drawing. It was 2.652. That's in the rejection region. So we are going to reject H naught. We're going to reject the null because this test statistic is actually greater than the critical value. So A, reject the null because the test statistic is less than the critical value. That's not good. Reject the null because the test statistic is greater than the critical value. Yep. All right, continue. P-value approach. Well, we already have our p-value. We look at our StatCrunch output. Our StatCrunch, our p-value is 0.004, which is less than 0.05, which is our level of significance. So again, we're going to reject. Where did it go? Here we go. Reject the null because the p-value is less than alpha. We always reject when the p-value is less than alpha. There we go. All right. The next problem I want to look at is 5. We've got 5 and then one more and we're done. All right. Just making sure I'm still recording. Okay. February 2008, the Gallup organization surveyed 1,034 adults between 30 and 64 years of age and found that 533 were worried that they will outlive their money after they retire. Does the sample evidence suggest that a majority of 30 to 60-year-olds in the U.S. Are worried that they will outlive their retirement? Well, it doesn't give us a test statistic to start with, but I'm thinking they're asking the majority. So a good test statistic would be H0 P equals 0.5, and H alternatives P is greater than 0.5. We're doing the alpha equals 0.05 level, 0.05. It's a right tail test. Z of alpha is 1.645. And our x, we'll write this all down. Our x is 533 over 1034. I'm thinking because they're saying majority that we can go ahead. This is an old sheet. All right, so let's write down what we know. And I'm going with 0.5 because it's asking us a majority. And so that would be a majority, greater than half. Okay. Alpha equals 0.05. Our Z of alpha is 1.645. So again, we've got a right tail test. There's our rejection, 0.645. And our X is equal to 533, and our N is equal to 1034. So that's all the data that we need. So what did I do? All right. Let's go back to StatCrunch. We can actually, you can just do options edit, but we'll go through stat, proportion statistics, one sample with summary. Number of successes was, that's your X, 533, over number of observations, which was 1034. H0 P is equal to 0.5, and the alternative would be that it's greater. Compute. All right. Now let's look at this. Our Z statistic, our proportion is 0.514. And that's our sample proportion. Our Z statistic was 0.995, and our p-value is 0.1598. So looking at our chart, 0.99, oops, I'm in the wrong one. I need to close one of these. 0.99 whatever is actually over here. So it's not in the rejection region. And again, our alpha was 0.05, and our computed p-value was 0.1598. So that's bigger than 0.05, so we would fail to reject. Let's see if we were right. Yep. Performance testing checks the correct answer. Well, we already knew. P-value approach, it's too big, reject the null. What? Oh, sorry, I hit the wrong one. It was do not reject the null. I know better. Just because we already said it's too big, we're not rejecting the null. It has to be smaller than alpha to reject the null. Duh. All right, one more and then we're done. Previously, 23% of employed adults were satisfied with their chances for promotion. The manager wants to determine if this percentage has changed significantly. She randomly selects 200 employees and finds that 56, so X equals 56, N equals 200. Is there sufficient evidence that the percentage of employees, adults satisfied with their chances for promotion is different from the previous? The previous percentage is P equals 0.23, that's H naught, and the alternative, it's really, they're not asking if it's greater or smaller or if it's just different. So it's just P not equal to 0.23. So let's write that out real quick. So this ends up being a two-tailed test. H naught, P equals 0.23. H alternative, P is not equal to 0.23. X equals 56. N equals 200. Let's see what else we need. What was the level of significance? 0.05. Alpha equals 0.05. And remember, this is, we're going to do Z of alpha over 2 because it's a two-tailed test. Either one of these are the rejection regions. So, come back to StatCrunch, Stat, Calculators, Normal. And we can find it on the left, 0.025, and we can find this number, negative 1.96. And on the right, I know, it should be the same number, 1.96. Okay, so we're going to use for a critical value 1.96, negative 1.96. And positive 1.96 if we had to do the Z. All right, so let's plug everything in to StatCrunch. Stat, proportion, statistics, one sample with summary. Number of successes. Oh, what did we not do? We did not make sure that N times P times 1 minus P is greater than or equal to 10. I think we have 200 times 0.23 times 1 minus 0.23 has to be greater than or equal to 10. Oh, here it is. So we've got 200. And then 1 minus 0.23, I can do that in my head. That's 77. Right, 77 plus 23, yep. 0.77 times 0.77. I think we're fine. Yep, we're fine. It's 35.042. So yes, we're good here. The number of successes was 56. The number of observations was 200. P is 0.23. P not equal to 0.23. Compute. All right. Well, our Z statistic was 1.68. And our P value is 0.0929. And our proportion was 0.28. Look at this. Well, it looks like 1.68 is just right around here. So that's not in our critical region. So according to the classical approach, we wouldn't reject. However, let's look at the p-value approach. Well, we're testing 0.05, and our p-value was calculated to be 0.0929, 0.05, and that's actually greater than 0.05. And the only time we reject is when our p-value is less than alpha. So both of these are telling me I'm going to fail to reject. Oops, I don't know where I am. All right, so we reject no. We do not reject. I'm just looking at this part. So A and C are out, and let's see what. Yes, there is sufficient evidence, meaning that we do not reject. Well, if there was sufficient evidence to say that the employed adult satisfied with chance of promotion is different, there would be significant evidence to say it was different. So if we read D, no, there is not sufficient evidence, meaning that we do not reject the null. There we go. Okay, that is all I have for you. So you guys, hopefully you've watched this, got something from it, and there will be no video for 10.4 and actually no real media because it's simply deciding between whether or not to use the t-statistic or the proportion statistic for 10.4. It's a good little practice for your test. All right, guys, take care.